Hi, AP Psych. These are your module point 4 video notes. This whole module is correlation and experimentation. This first part will be just about correlation, which, if you remember from a previous set of notes, that is a non experimental research method. And then separately, I'll go into experimentation. So, our learning targets, there's quite a few. I can determine whether a study is using experimental or non experimental methodologies. I can identify the independent variable, dependent variable, and or confounding variables in a research scenario. I can identify the experimental and control groups, including the process and purpose for assigning people to groups, whether a placebo was used with the control group, and the effect of the placebo on the results. I can determine whether the study used single blind or double blind procedures to control for confounding variables like experimenter bias or the social desirability bias. A few more. I can identify the variables of interest in a research scenario. I can evaluate whether the results of a correlational study have a directionality problem or third variable problem that demonstrates that correlation does not equal causation. I can determine whether the measurement instrument for experimental research used qualitative, such as structured interviews, or quantitative measures, such as Likert scales. And finally, I can describe trends in and relationships between the variables as depicted in the data presented, such as interpreting correlational data from a scatter plot, including the correlation coefficient. So again, this is a non-experimental method, correlations. I could have included this with our previous set of notes. However, there's quite a bit here, so I wanted to separate it out for correlations. So first, what is a correlation? So it's a non-experimental measure of the extent to which two factors, two variables, vary together, and thus of how well either factor predicts the other. So essentially, we're looking at relationships between variables without manipulating either one. And by manipulating, meaning we're not changing anything about the variables, we're simply describing them as they are. The pros for using correlations is they are great at predicting behavior, and we can use pre-existing or archival data um, that was gathered in various means. Therefore, we don't need any participants in order to do it. The cons, just like our other non-experimental measures, it does not lead itself for causality, meaning it cannot actually explain behavior. And there could be what's called a directionality problem, meaning we don't know which variable is really impacting the other, as well as something called a third variable problem that we'll talk about here in just a moment. So in this corner here, I have the scatter plot showing a correlation for Google searches for that is sus in Lululemon's stock price. So, just to give you an idea of kind of where we're going with this, correlations means there is a relationship between these two variables. We can see it here on the scatter plot. However, we cannot say that searches for this is sus causes Lululemon stock price to go up, nor can we say Lululemon stock prices causes people to search for that is sus. The way we represent correlations graphically is through a scatter plot. So, a scatter plot is a graphed cluster of dots, each of which represents the value of a variable. The slope of the points tells us the direction of the relationship between the variables, and the amount of scatter, meaning how close the dots are together or how spread apart they are on the graph, tell us the strength of the correlation. So, for example, little scatter, meaning that they're very close together, indicates a high correlation or a strong relationship. We're going to define a variable as anything that can vary, meaning anything that can change, and is feasible and ethical to measure. So it could be something as silly as Google searches of this is sus to student grades. So these are what scatter plots look like. So we can see we have in all of these three, we have two variables, for example, ice cream sales and crime rates, absenteeism and grades, and finally shoe size and colors in a rainbow. And what we're talking about in terms of scatter is you can see these have very little scatter and they form almost a straight line. For my stats people, we'll learn this is called the line of best fit. Or we can see them very scattered, meaning you see no sense of a line as we see over here. And what this tells us is the strength of the relationship. And in addition, by looking at which direction this line goes, for example, up to the right versus down to the right, it tells us whether this is a positive or negative correlation. So here's what that means. A positive correlation means when one variable increases, so does the other, or when one variable decreases, so does the other. I like to say that the variables move in the same direction. So they either both go up or they both go down. So we can see in this that as ice cream sales go up, crime rates also go up. Now, be careful here. This is not saying that higher crime rates lead to higher ice cream sales or that more ice cream sales lead to or cause more crime. It's simply saying that they have a relationship. Here in this middle scatter plot, we have a negative correlation depicted. What this means is as one variable increases, the other variable decreases. So in this case, we can see that as students miss more school, their grades decrease. So as one goes up, the other goes down. That is always going to be a negative correlation. And finally, we can see that there's no correlation or no relationship between two variables on this scatter plot because we see no semblance of a line anywhere. The dots are literally all over the place. That means there's zero correlation between someone's shoe size and colors in a rainbow. The other way that we can represent correlations is through the variable R, which stands for the correlation coefficient. And this is a statistical index of the relationship between the two variables. This is always going to fall somewhere between negative 1.0 to positive 1.0. And this number or this correlation coefficient, R, tells us the strength of the relationship. So the closer the absolute value of the coefficient is to 1, the stronger the correlation between the variables. The closer they are to 0, the weaker the relationship is to the variables. So we can see this works, if you see where I'm moving my mouse, both with a positive and a negative correlation. So in terms of strength, positive 0.5 is the same strength as negative 0.5. All the negative or positive tell us is this a positive correlation, meaning the variables moved in the same direction? Or is this a negative correlation, meaning the variables moved in opposite directions? As one went up, the other went down. The closer the number is to 0, whether it's a positive 0.10 or a negative 0.10, those are equally weak. So we're going to do a little bit of retrieval practice to see how we are doing with this concept. So first, we're going to look at number 1. So which indicates a stronger relationship? So I want you to think about of these two numbers, what do you think is stronger? So I probably should have warned you ahead of time that I was going to ask you all 4, but I'm going to fix that in the Edpuzzle so you will get asked about all 4 of these. So here are your answers. I forgot I put them all on one slide. So first, the stronger relationship for number 1 is negative 0.70. For number 2, it's negative 0.89. For number 3 is positive 0.33. And for number 4 is negative 0.54. Notice that it does not matter whether it's negative or positive. The closer to either -1 or +1 indicates the stronger relationship. Now let's do another retrieval practice using the scatter plots. So, which do you think indicates a stronger relationship? Is it scatter plot A, B, C, or D? Go ahead and select. And for this, the correct answer is C. And the reason we know that is because this forms more of a straight line, meaning there's less scatter in comparison to the other scatter plots. Now, A and B are decently strong correlations, but not, they're stronger than D, which we can see does have a little bit of a correlation. We can kind of see where that line of best fit would be, but not nearly as strong. And another one, which of these indicates a negative correlation? This is a little bit of a trick question because not only should it be letter B, but I could also have letter C. So if you had B or C, or hopefully you recognize that it's both of these are indicating a negative correlation. That's because it slopes down to the right. And finally, which one indicates no correlation or a very weak correlation? I kind of already told you the answer to this. And the correct answer would be D. Maybe no correlation is a little bit strong, but it's definitely weaker in comparison to the other three. So, what we need to understand about correlations is correlations do not mean causation. You've heard me say this a few times, where if we're doing non experimental research, we cannot determine causation, meaning we cannot say X caused Z. A strong correlation might indicate causality, but in order to find that out, we would have to do an experiment. But we also need to understand that there could be other explanations for why there's such a strong correlation. It could be chance, but there's no actual relationship between them. And to give you another example here of correlations of air pollution in Boulder and Google searches for how to trap a spider, again, there's a correlation here, um, but it doesn't mean that one caused the other. One of the things that we need to be aware of is called the third variable problem. So, the third variable problem refers to the fact that two variables that are correlated, such as we see in this image here, ice cream sales and sunburn rates, there's a correlation between them, okay? But may not be directly related to one another. In fact, they might be related both to a third variable, that it's summertime. So, summertime may lead to higher ice cream rates, and summertime, or it being hot outside, might lead to more sunburn rates. Hence, both of these individually are related more towards it being summer than they are to each other. So, this is a third variable impacting both of these. Sometimes we also get what are called illusory correlations, meaning we may believe there's a relationship between two variables when in fact there's either none or a weaker than we believe there is relationship. So, for example, if we ask people about the impact of a full moon on behavior, there are lots of people that believe that full moons lead to people acting up, being weird, going into labor, that we get more patients or weird behavior coming into hospitals or to ERs. So that might lead people to say, oh, full moons cause people to act a certain way. When in fact, it could just be coincidental. or that relationship may be less strong than what people believe. We also need to be aware of something that happens called regression towards the mean. So, this is the tendency for extreme or unusual scores or events to fall back, meaning regress, to the average. So, for example, if someone is studying math interventions, regardless of the math interventions that a researcher is investigating to help improve someone's math performance, for example, providing extra study sessions, providing things like positive reinforcement, like rewards for scoring well, low scoring students will tend to perform slightly better on the next math exam, whereas higher scoring students will tend to perform slightly worse, meaning they have this natural tendency to go back to their average. One way to try to combat this is using something called random assignment that we'll talk about when we get to experiments, which may minimize the influence of regression towards the mean on our results. A little bit of retrieval practice, and then we are done. So, first, which of the following is an example of a negative correlation? Go ahead and respond. Hopefully, you said A, people who spend more time exercising tend to experience less depression. This is the answer because as exercise time increased, depression rates, it says less depression, decreased. The variables are moving in different directions, meaning it is a negative correlation. Next, researchers have discovered that individuals with lower income levels report having fewer hours of total sleep. Therefore, which of these answer choices fits this scenario best? Go ahead and answer. Hopefully, you said A, that income and sleep levels are positively correlated. That means as one goes down, the other also goes down, meaning these variables are moving in the same direction. We might be tempted to say letter D, that lower income levels cause individuals to have fewer hours of sleep. However, without doing an experiment, we cannot come to that conclusion. So A is our best choice. Next, of these answer choices, which of the following correlation coefficients represents the weakest relationship between two variables? Go ahead and respond. The correct answer is D, negative 0.30. Remember, we want to get closest to 1, whether that's positive 1 or negative 1. And letter B, 1.3, isn't correlated at all because it will always be no higher than 1. And that is it for this set of notes. We will get to experimental methodology next.